The second type of important distortion of the octahedron involves stretching out the two end points. When I think of these as opposite sides and we stretch these out, the effect is that this base stays exactly the same, but these two sides of the triangle increase. So it goes from being a perfect equilateral triangle to becoming a isosceles triangle. So this we call a tetragonal distortion, and we can reason why it's called tetragonal. If we look down the axis, we can see that we still have the C4 rotational axis. So in this dimension, we still see the square. Let me show that again. See the square sort of structure. But when we go this way, no longer the perfect triangles that we had before. Now, how this occurs typically is we can think of it conceptually as taking the two ligands at the end and pulling them further and further apart. Typically, we define this particular axis to be the z-axis, and then this particular plane is the xy plane. So as we withdraw the ligands further away along the z-axis, the electrostatic repulsion between the ligands and the dz squared orbital is reduced. Because of that, the dz squared orbital will come down in energy. And in fact, any orbital that has a z component will drop in energy. So for example, of the EG stars, we have dz squared. As we tetragonally distort, as we pull the ligands further away along the z-axis, dz squared will drop in energy. Among the T2Gs, the xz, dxz, and dyz will also drop in energy. So that's an important shift that we have in the tetragonal distortion. So this changes from the 2 on top, 3 on bottom, EG star, T2G pattern to a more complicated pattern where the highest level of degeneracy that we have is 2. So we go from triply degenerate to doubly degenerate. And if we pull the ligands completely off, we can conceptually see how we would arrive at a square planar complex. So we can think of the octahedral complex, the tetragonally distorted octahedron, down to the square planar complex, all as manipulations of the octahedral setup. And we can predict quite well the directions of the energy changes of particular d orbitals in those cases. So again, it all starts with the octahedron. Just as in football, it all starts up front with the blocking. Well, with the octahedron, it all starts with the 5 d orbitals and the particular symmetry splitting patterns we get when we put them in a ligand field. Remember that the ligands cause electrostatic repulsion with the various d orbitals, and that changes their energies. This is all for episode 8. Next time, episode 9. Have a good one.